Namaste students, welcome to today's mathematics class. In the last class, we have learnt different combinations of multiplication of algebraic expressions. Those are multiplication of monomial by a monomial, multiplication of 3 or more monomials, multiplication of monomial by a binomial, multiplication of monomial by a trinomial, and multiplication of binomial by a monomial. In today's class, we will learn the other combinations of multiplication of polynomials. Are you ready to learn? Good. Multiplying a polynomial by a polynomial. Out of that, we first learn multiplying a binomial by a binomial. Let us multiply one binomial, say 2a plus 3b, by other binomial, say 3a plus 4b. We do this step by step by following distributive law. Problem 1, 3a plus 4b times 2a plus 3b is equal to 3a times 2a plus 3b plus 4b times 2a plus 3b, which is equal to 3a into 2a plus 3a into 3b plus 4b into 2a plus 4b into 3b. Observe here, every term in one binomial multiplies every term in the other binomial, which is equal to 6a square plus 9ab plus 8ba plus 12b square, which is equal to 6a square plus 17ab plus 12b square, since ba is equal to ab. When we carry out term by term multiplication, we expect 2 into 2 4 terms to be present, but 2 of these are like terms which are combined, and hence we get 3 terms. In multiplication of polynomials with polynomials, we should always look for like terms, if any, and combine them. Try to solve this problem on your own. Problem 2, y minus 8 into 3y minus 4. Multiplying a binomial by a trinomial. In this multiplication, we multiply each of the 3 terms of the trinomial by each of the 2 terms of the binomial. We shall get in all 3 into 2 is equal to 6 times. We may reduce to 5 or less terms if the term by term multiplication results to like terms. Let us consider this problem. Problem 3, a plus 7 times a square plus 3a plus 5, whereas a plus 7 is a binomial, a square plus 3a plus 5 is a trinomial, which is equal to a times a square plus 3a plus 5 plus 7 times a square plus 3a plus 5. Using distributive law, we get a cube plus 3a square plus 5a plus 7a square plus 21a plus 35, which is equal to a cube plus 3a square plus 7a square plus 5a plus 21a plus 35. Here you see we have written the like terms together, which is equal to a cube plus 10a square plus 26a plus 35. Here 3a square and 7a square are like terms. So, when we add them, we get single term. Similarly, 5a and 21a are like terms. So, when we add them, we get single term. Hence, the product of a plus 7 and a square plus 3a plus 5 has 4 terms. Is it not interesting? Good. Try to solve this problem on your own. Problem number 4. Simplify x plus y times x square minus xy plus y square. X square plus 3x plus 2 is equal to 132 and x plus 1 times x plus 2 is equal to x square plus 3x plus 2. Both are algebraic equations as they contain variable x, constants and coefficients. Let us explore the difference between both of them. What is an identity? An equality which is true for every value of the variable in it is called an identity. Let us consider this equality. X plus 1 times x plus 2 is equal to x square plus 3x plus 2. We shall evaluate both sides of this equality for some values of x. Say x is equal to minus 5, minus 10, 0, 5 and 10. Did you observe that for the above values of x we got LHS is equal to RHS? Similarly, we can find for any value of x LHS is equal to RHS. Such an equality which is true for every value of the variable in it is called an identity. Thus, x plus 1 times x plus 2 is equal to x square plus 3x plus 2 is an identity. An equation which is true only for the certain values of variables in it. It is not true for all the values of the variable. Let us consider the following example. X square plus 3x plus 2 is equal to 132. We shall evaluate both sides of this equation for some values of a. Say a is equal to minus 5, minus 10, 0, 5 and 10. If you observe that the values in the above table is true only for x is equal to 10, but it is not true for other values of a. So, x square plus 3x plus 2 is equal to 132 is not an algebraic identity. Standard identities. We shall now learn 3 identities. These identities are obtained by multiplying a binomial by a binomial. Let us consider the first identity, that is a plus b whole square is equal to a square plus 2ab plus b square. Let us consider the product a plus b times of a plus b or a plus b whole square. A plus b whole square is equal to a plus b times of a plus b. By using distributive property, a times of a plus b plus b times of a plus b, which is equal to a square plus ab plus ba plus b square, which is equal to a square plus 2ab plus b square. Why? Because ab is equal to ba. Thus, a plus b whole square is equal to a square plus 2ab plus b square. Clearly, this is an identity since the expression on the RHS is obtained from the LHS by actual multiplication. One may verify that for any values of a and b, the values of the two sides are equal. Let us see the geometrical representation of the identity a plus b whole square is equal to a square plus 2ab plus b square. Here is the square of length a plus b. Can you guess what its area is? Its area is a plus b whole square. We shall now cut this square into 4 parts as shown in the figure. After cutting, we get square whose area is a square, a rectangle whose area is AB, another rectangle of area AB and a square of area B square. On adding all these areas, we get a plus b whole square is equal to a square plus AB plus AB plus B square. Thus, A plus B whole square is equal to A square plus 2AB plus B square. We now learn identity 2, that is A minus B whole square is equal to A square minus 2AB plus B square. Are you ready to learn? Good. Consider A minus B whole square is equal to A minus B times A minus B. By using distributive property, we get A times A minus B minus B times A minus B. We have A square minus AB minus BA plus B square, which is equal to A square minus 2AB plus B square. Why? Because here AB is equal to BA, that is A minus B whole square is equal to A square minus 2AB plus B square. Let us see the geometrical interpretation of the identity 2, that is A minus B whole square is equal to A square minus 2AB plus B square. Consider the square of length A. Now choose the length B along the sides and mark the point as shown in the figure. Join all the points through straight lines. Now cut the square along these straight lines. On cutting, we get 4 different parts. They are a square of area A minus B whole square, a rectangle of area B into A minus B, another rectangle of area B into A minus B, and a square of area B square. On adding all these areas, A minus B whole square plus B times A minus B plus B times A minus B plus B is equal to A square, which is our original square. We now learn identity 3, that is A plus B times A minus B is equal to A square minus B square. Are you ready to learn? Good. Consider A plus B times A minus B. A plus B times A minus B is equal to A times A minus B plus B times A minus B. Here we use distributive property, which is equal to A square minus AB plus BA minus B square, which is nothing but A square minus B square. Can you tell me why it is? Because AB is equal to BA. Good. That is nothing but A plus B times of A minus B is equal to A square minus B square. Let us see the geometrical interpretation of the identity 3, that is A plus B times A minus B is equal to A square minus B square. Consider the square of length A. Choose the length B along any 2 adjacent sides of a square as shown in the figure. Make square of length B as shown in the figure. Now cut the small square from the big square. Can you guess what would be the area of the remaining part? Good. It is A square minus B square. Let us now consider the bigger part. Now observe from the figure, there is a rectangle B into A minus B. Let us now cut this rectangle and place it as shown in the figure. We now got the new rectangle of length A plus B and width A minus B. Therefore, the length of this rectangle is A plus B into A minus B, which is our bigger part. This is equal to A square minus B square. Therefore, we have A plus B into A minus B is equal to A square minus B square. These identities 1, 2 and 3 are called the standard identities. Let us see how to get identity 2 from identity 1. Identity 1 is A plus B whole square is equal to A square plus 2AB plus B square. We now put minus b in place of b in the above identity 1. We get a minus b whole square is equal to a square plus 2a times minus b plus minus b whole square, which is equal to a square minus 2ab plus b square, which is nothing but identity 2. Is it not interesting, students? Good. We shall now work out one more useful identity. Are you ready to learn? Good. X plus a times x plus b is equal to x times of x plus b plus a times of x plus b. In the above step, we used distributive property, which is equal to x square plus bx plus ax plus ab, or x plus a times x plus b is equal to x square plus a plus b into x plus ab, which is the identity number 4. Let us see the geometrical interpretation of the identity number 4, that is x plus a into x plus b is equal to x square plus a plus b into x plus ab. Consider the rectangle of length x plus a and breadth x plus b. Now, the area of this rectangle is x plus a into x plus b. After cutting, we get a square whose area is x square, a rectangle whose area is x into a, another rectangle whose area is x into b, and one more rectangle whose area is a into b. If you add all these areas part by part, we get the area of the original figure, that is x plus a into x plus b is equal to x square plus xa plus xb plus ab. If you take x as common from second and third terms of RHS, we get x square plus x times of a plus b plus ab. Let us consider the special case of identity number 4 with a is equal to b. What do you get? Is it related to identity number 1? Let us see. Identity number 4 is x plus a times x plus b is equal to x square plus a plus b into x plus ab. Let us put a in place of b. We get x plus a times of x plus a is equal to x square plus a plus a into x plus a into a, that is x plus a whole square is equal to x square plus 2ax plus a square, which is nothing but identity number 1. Yes, it is related to identity number 1. Consider the special case of identity 4 with a is equal to minus c and b is equal to minus c. What do you get? Is it related to identity 2? Let us see. Identity 4 is x plus a into x plus b is equal to x square plus a plus b into x plus ab. We now put a is equal to minus c and b is equal to minus c. We get x minus c into x minus c is equal to x square plus minus c into x plus minus c into minus c. X minus c whole square is equal to x square minus 2cx plus c square. Yes, it is related to identity 2. Consider the special case of identity 4 with b is equal to minus a. What do you notice? Is it related to identity 3? Let us see. Identity 4 is x plus a into x plus b is equal to x square plus a plus b into x plus AB. We now put B is equal to minus A, we get x plus A into x plus of minus A is equal to x square plus A plus of minus A into x plus A into minus A. X plus A into x minus A is equal to x square plus A minus A into x minus A square, that is equal to x square minus A square. Yes, it is related to identity 3. Now, we could see that identity 4 is the general form of the other 3 identities. Applying identities, we shall now see how for many problems on multiplication of binomial expressions and also of numbers, use of the identities gives a simple alternative method of solving them. Problem number 5. Using the identity a plus b whole square is equal to a square plus 2ab plus b square, find 2x plus 3y whole square. Solution. By comparing with the identity, we have a is equal to 2x, b is equal to 2y. We now substitute the values of a and b in the identity. We get 2x plus 3y whole square is equal to 2x whole square plus 2 into 2x into 3y plus 3y whole square, that is equal to 4x square plus 12xy plus 9y square. We now find 2x plus 3y whole square by direct multiplication. 2x plus 3y whole square is equal to 2x plus 3y into 2x plus 3y. By using the distributive property, we get 2x into 2x plus 2x into 3y plus 3y into 2x plus 3y into 3y, that is equal to 4x square plus 6xy plus 6yx plus 9y square, as xy is equal to yx, that is equal to 4x square plus 12xy plus 9y square. Using the identity a plus b whole square is equal to a square plus 2ab plus b square gave us an alternative method of squaring 2x plus 3y. Do you notice that identity method requires fewer steps than the above direct method? Yes, you are right. You will realize the simplicity of this method even more if you try to square more complicated binomial expressions than 2x plus 3y. Problem number 6. Using the identity a plus b whole square is equal to a square plus 2ab plus b square, find 103 whole square. Solution. 103 whole square. How shall we write 103 as sum of two numbers? Yes, you are right. 103 is equal to 100 plus 3. 103 whole square is equal to 100 plus 3 whole square, that is equal to 100 square plus 2 into 100 into 3 plus 3 square. Using the identity a plus b whole square is equal to a square plus 2ab plus b square, 103 whole square is equal to 10,000 plus 600 plus 9 is equal to 10,609. We may also directly multiply 103 by 103 and get the same answer. Try yourself. You will see that a plus b whole square is equal to a square plus 2ab plus b square gives us less tedious steps than direct method of squaring 103. Problem 7. Try yourself. To find the square of 1013, you will find in this case the method of using identities even more attractive than the direct method of multiplication. We now find the square of a number by using identity 2, a minus b whole square is equal to a square minus 2ab plus b square. Problem number 8. Using the identity a minus b whole square is equal to a square minus 2ab plus b square, find 4.9 whole square. How shall we write 4.9 as difference of two numbers? Yes, you are right. 4.9 is equal to 5 minus 0.1. 4.9 whole square is equal to 5.0 minus 0.1 whole square, that is equal to 5.0 whole square minus 2 into 5.0 into 0.1 plus 0.1 whole square, that is equal to 25.00 minus 1.00 plus 0.01, that is equal to 24.01. Let us take one more problem. Are you ready? Good. Problem number 9. Now, you try to find 4.9 whole square by direct multiplication on your own and tell me which method is easy. Problem 10. Using the identity 3, a square minus b square is equal to a plus b into a minus b, find 983 square minus 17 square. 983 square minus 17 square. By comparing with the identity a square minus b square is equal to a plus b into a minus b, can you tell me the values of a and b? Yes, you are right. A is equal to 983 and b is equal to 17. We now substitute the values of a and b in the identity a square minus b square is equal to a plus b into a minus b. We get 983 square minus 17 square is equal to 983 plus 17 into 983 minus 17. Therefore, 983 square minus 17 square is equal to 1000 into 966, that is equal to 9,66,000. Is it not interesting? Shall we try one more problem? Very good. Problem number 11. Try to find 983 square minus 17 square directly. You will realize how easy our method of using identity. Problem number 12. Using the identity a square minus b square is equal to a plus b into a minus b, find 153 square minus 147 square on your own. Problem number 13. Use the identity x plus a into x plus b is equal to x square plus a plus b into x plus ab to find 501 into 502. Solution: 501 into 502. How can we write 501 and 502 as sum of two numbers? Good, you are right. 501 is equal to 500 plus 1 and 502 is equal to 500 plus 2. Therefore, 501 into 502 is equal to 500 plus 1 into 500 plus 2. By comparing with the identity x plus a into x plus b is equal to x square plus a plus b into x plus ab, we have x is equal to 500, A is equal to 1, B is equal to 2, and we substitute the values of x, A, B in the identity. We get 501 into 502 is equal to 500 square plus 1 plus 2 into 500 plus 1 into 2, that is equal to 2,50,000 plus 1,500 plus 2, that is equal to 2,51,502. Try to solve this problem on your own. Problem number 15. Using the identity x plus a into x plus b is equal to x square plus a plus b into x plus ab, find 103 into 104 yourself. Let us summarize what we have learnt today. We solved some problems on algebraic expressions. We learnt the definition of algebraic identity. We applied algebraic identities while solving the problems. Hope you all enjoyed the today's class. Wear mask, maintain social distance, stay safe at home. Thank you.